Prep Station, SSCE Tutorials, Geography. For this session, we'll be considering some topics in physical geography. Some of the topics include mountain, volcanicity, and earthquake. So let's quickly start with the first one, mountain. Mountain. This is a landform that rises above the surrounding land, usually with steep sides. Even from the picture illustration here, you can see that it rises with very high elevation, and you see the sides of the mountain are steep. Mountains are typically higher than the hills and have a limited summit area. This is what we call the summit area. The summit area is relatively small and the base is large. So mountains are landform that rises above the surrounding land. Characteristics of mountains. Mountain has prominence as it rises significantly higher than the land around it. Anywhere you have mountain, you see that it will stand out. Even from a distance, you'll be able to see the mountain. That's why we say it's significantly higher than the land around it and has prominence. Number two, the climate at the summit of the mountain are different from that of the surrounding area. With your knowledge of environmental lapse rate, as you go, the colder it becomes. So the temperature drops at 6.5 degrees for every 1 kilometer of ascent. So the higher the mountain, the colder it will be at the peak of that mountain. So ideally, the top of the mountain has a different climate than the what you have at the base or the foot of the mountain. Mountains can be formed by folding, faulting, and volcanic activity. So these are the various processes that is used to make mountain. Mountain can be formed by folding, we have fold mountain. It can also be formed as a result of faulting and volcanic activity. Mountains typically have steep slopes and are understood to be higher than the hills. They have steep slopes and are understood to be higher than the hills. We'll be looking at the 4 types of mountain: the block mountain, the fold mountain, the volcanic mountain, and the residual mountain. Block mountain. These are mountains formed as a result of faulting. Faulting has to do with development of cracks, tiny cracks. So block mountain is formed as a result of faulting or crack. And when this faulting or crack occurs, with time, with continuous stress, that crack will widen, that very tiny crack will widen. When that crack widens with time, either the middle segment of that landmass will subside, leaving the 2 other stages to remain upstanding, giving us a rift valley. Or the 2 sides of the blocks will subside, leaving the middle side to upstanding. So block mountains are associated with the formation of rift valley. The elevated part of the block mountain is what we call the graben, the side that will be pushed up. And then, note that the name block mountain is derived because of the rectilinear shape of the mountain. It is formed as, it takes the shape of a block. That's why we call it block mountain. As I said, block mountains are associated with the formation of rift valley. So this is the diagrammatic illustration of how block mountain is formed. These are the fault lines. So this fault has segmented this block into 3 parts. This part, the middle, and this. So if it happens that it's the middle part that sinks, leaving this one and this one to be upstanding, it will result in the formation of rift valley. But if it happens the other way around, that in this fault line, this other side, the left side and the right side, will subside, leaving the middle side to be upstanding. That type is what we call the host. The side that will come down is the graben, and the side that will go up is the host. Examples of block mountain. We have the Vosges Mountain in France. We have the Black Forest Mountain in Germany. Fold mountain. Fold mountain. It is formed as a result of compressional forces. Compressional forces. These are mountains formed due to compressional stress that causes the earth crust to wrinkle. Wrinkle. Remember, the name is fold mountain. So when there is compression forces, it will cause the landmass to wrinkle. And when it wrinkles, some of the portion of the land will fold up. That part that is folded up is called anticline. And some part will squeeze in. And that part that is squeezed in is called syncline. So just like we have in the host and gabbro for block mountain, the aspect of fold mountain, we have the anticline and the syncline. So fold mountain are formed when the earth movement push huge slab of the earth's crust called tectonic plates. And these bubble up or fold. The layer of the rock that is folded up towards the summit is called the anticline, and the side that folds down is what is called the syncline. Examples of fold mountain: the Himalayas stretching between China, India, and Nepal. We also have the Alps stretching between France and Italy. We also have the Rocky Mountains in North America. This is a diagrammatic illustration of the fold mountain. You can see the compressional stress coming together, causing the land to fold. Volcanic mountains. Volcanic mountain. It is mountain formed as a result of volcanic activities. Volcanic activities. All right. Volcanic mountains are formed by the accumulation of lava. From the diagram here, this is the accumulation of lava. So when this lava finds its way to the surface of the earth, it will cool down and then form what we call the volcanic mountain. So these are the lavas coming out from deep beneath the earth crust to the surface. From this, you can see other layers of the lava that have cooled down and solidified. So each time the volcanic mountain erupts, it will bring forth new sets of magma, and then this magma will cool down, solidify, thereby making the mountain to continue to accumulate in height. A volcanic mountain is formed by the eruption of magma from the earth's core. The magma cools and hardens into lava, which builds up around the volcanic vent to form a cone-shaped mountain. So the diagram illustrates what we call the volcanic mountain. Example, the Kilimanjaro mountain in Tanzania, the Cameroon mountain in Cameroon, the Mount Fuji in Japan, the Mount Fuji in Italy, Mount Etna in Sicily, and Mayon volcano in Philippines. Residual mountain. Residual mountain. Another name for residual mountain is mountain of denudation. Mountain of denudation. Residual mountains are remnants of heavy resistant rock that could not be eroded by erosion agents such as wind, rain, or snow. The mountain constitutes the residue. The name is residual mountain. This type of mountain are the resistance remnants of an already existing mountain. The resistance remnants of an already existing mountain. That's why we call it residual mountain. So these mountains constitute the residue or the left behind of pre-existing fault block of volcanic mountain that have been washed off by agents of erosion. Hence the name residual mountain. Another name for residual mountain is mountain of denudation. This is a diagrammatic illustration of residual mountain. This is the original mountain as it were. So this represents the softer layer, and this dark brown area represents the resistant rock. You can see that in this other diagram, the soft rocks are no longer there. The soft rocks have been eaten up or washed off by agents of denudation, such as wind and rainwater or erosional water, leaving behind the hard resistant part. So these hard resistant parts that cannot be taken off by agents of denudation now constitute what we call the residual mountain. Examples of residual mountain: Mount Monodoc in the United States of America, the Scandinavian Highlands, and the Matterhorn in Switzerland. Importance of mountains. Number one, they are source of rivers. Number two, they are good sites for ecotourism. Some people go for hiking in the mountain. Some people go for mountain climbing. These are tourism potentials of the mountain. Number three, they are used as natural boundaries separating countries or communities. Some mountains constitute boundary that separates countries or even some communities. One of the boundaries separating Nigeria from Cameroon is a mountain. They are source of minerals. Number five, mountains serve as natural defense against invaders. In terms of external aggression, communities that are on top of the mountain are on advantage because that mountain will serve as a defense. As intruders or invaders are coming, those at the top of the hill can see in advance and prepare their defense. Number six, mountains are the basis for research. Yes, mountains are the basis of research. So mountains are being researched upon to know some of the phenomena that is associated with the existence of such mountain, the geological processes that leads to the formation of those mountains. Today we talk about fold mountain, block mountain, volcanic mountain, because such mountains has been researched upon. Mountain influences the climate of the surrounding area. Remember, I told us that the type of climate at the top of the mountain and that at the base of the mountain are not the same. So these are the influence of climate or mountain on climate. Problems. In as much as we have some importance of mountain, we also have challenges from the mountain. One of it is that mountains hinder the construction of roads. Construction routes will always avoid transportation routes always avoid where you have mountains because it is very, very difficult to construct road across mountains. You have to do so much excavation and the rest. Number two, mountains are barriers to communication network. Wherever you have mountain, that mountain can be blocking electromagnetic wave, and this is a barrier to communication. Mountains hinder the takeoff and landing of airplanes. Airports are always sited away from where you have mountains because mountains hinder takeoff and landing of airplanes. Number four, some mountains constitute bad land that cannot be utilized for arable farming. Mountains facilitate soil erosion due to the speed of the surface runoff coming down the slope. Let's look at some of the past questions on mountains. Objectives. Number one, mountains form as a result of compressional forces. I have to stress the word there. Compressional forces in the earth crust are A, block mountain, B, fold mountain, C, volcanic mountain, D, residual mountain. So the right answer there is B, because we are talking about compressional forces. Compressional forces, fold mountain. Number two, the upfolded portion, upfolded portion of a fold mountain is called A, host. No, host is not the correct answer. Host has to do with block mountain. Anticline, syncline, seal. Seal has to do with vertical or horizontal intrusion of molten magma. So it has nothing to do with fold mountain. So we have to contemplate our answer between anticline and syncline, B and C. So the upfolded portion of a fold mountain, the right answer is anticline. Anticline is the upfolded portion of the fold mountain, and then the downfolded portion is the syncline. Anticline for the upfolded portion of the fold mountain. Number three, the most satisfactory explanation for the formation of a fold mountain is A, faulting, B, volcanicity, C, compressional force, D, tensional force. Fold mountain, fold mountain, fold mountain. So the right answer is compressional force. The process that leads to formation of residual mountain is A, compression. No, compression has to do with fold mountain. B, denudation. C, faulting. D, volcanicity. The right answer is denudation. Denudation, which is option B. Option B, denudation. Host is a feature associated with A, volcanic mountain, B, residual mountain, C, block mountain, D, fold mountain. The right answer is option C, which is block mountain. Which of the following is not a type of mountain? Which of the following is not a type of mountain? A, conical mountain, B, block mountain, C, fold mountain, D, volcanic mountain. The question is not. So the right answer is A, which is conical mountain. There is nothing like conical mountain. Which of the following landform is associated with parallel faulting? Parallel faulting. Fault has to do with tiny cracks that will eventually widen up. So we have dike, we have in-cell bed, we have gorge, we have rift valley. The right answer is option D, which is rift valley. It is rift valley. It is a faulting. From faulting, we can have the subsidence of one of the portions to give rift valley, and then the remaining standing part is what will constitute the block mountain, the host. A block mountain is formed as a result of A, differential erosion, B, volcanicity, C, faulting, D, feature. Block mountain. The right answer is faulting, which is option C. Which type of mountain is also called mountain of denudation? We have option A, block mountain. We have B, volcanic mountain. We have residual mountain. We have D, fold mountain. Mountain of denudation. That's the alternative name for residual mountain, which is option C. Volcanicity implies the processes associated with the formation and ejection of molten magma, ash, and other materials from beneath the Earth's crust to the Earth's surface. The processes of volcanism or volcanicity includes, number one, the bedrock will be subjected to intense heat and pressure. As a result of that, some of them will become melted to semi-liquid states, molten states. Number two, when there is crustal disturbances, that's vibration or shift in the earth crust, this semi-liquid magma will now force its way into the cracks or the fissures of the earth and then come to the surface. Based on the prosperity of eruption, we can classify volcanoes into active volcano, dormant volcano, and extinct volcano. Active volcanoes are those volcanoes known for their frequent eruptions. Dormant volcanoes are those ones that are known to have erupted and with signs of possible future eruption. They are just lying fallow for some time. And then extinct volcanoes, those ones have lost the possibility of eruption. They are no longer active. What are the materials ejected during volcanic eruption? We have gases like carbon dioxide, sulfur dioxide, hydrogen sulfide, carbon monoxide. We also have heat or steam that comes out through the vents. We have lava, hot magma that is released as lava. We have ash. Volcanic ashes and dust particles are released into the atmosphere. Carbon dioxide, sulfur dioxide, hydrogen sulfide, and carbon monoxide as the gases. Regions of occurrence of volcanicity. Volcanic eruptions are common to places around the Pacific Ring of Fire, common to places around the Pacific Ring of Fire, such as Indonesia, Japan, New Zealand, Philippines, Mexico, United States of America, Russia, Chile, and Taiwan. Landforms of volcano. Now, at the cause of volcanic eruption, the magma or the lava can successfully travel up to the surface of the earth. And when this happens, we can have extrusive features of volcanoes. It can also happen that as the magma is coming or the lava is coming, it will cool down deep in the earth and solidify. And this will now form intrusive features of volcano. So we'll be looking at the extrusive features of volcano and intrusive features of volcano. For extrusive features of volcano, we have composite cones, lava domes, ash and cinder cones, and caldera. This is the composite cone. From this picture illustration, this is the primary vent where the lava escapes, and the one by the side is what we call the secondary vent. This is the cinder cone volcano. You can see the steep side, and then it composes of ash and cinder. We could also have shield volcanoes. You can see the shape. We have composites. You've seen the primary vent and the secondary vents. This one is like the dome, the lava dome, and then you have the cinder cones. Intrusive landform of volcano. These are the kind of volcano that solidifies, cools and solidifies before they make it to the surface of the earth. Here we have the dike, vertical mass of magma. Vertical mass of magma. We have the laccolith. That's when the magma solidifies to assume a dome shape. We have the seal, which is horizontal intrusion of magma. We have lapolith, which is a syncline or saucer-shaped magma. We have the falcolith, like a lens shape of magma, occupying the crest and anticline of the landmass. Then we now have the batholith, which is a huge mass of igneous rock, which eventually becomes exposed by denudation. Effects of volcanicity. When there is volcanic eruption, there will be loss of lives and property through submergence and displacement of settlements. Number two, the volcanoes will destroy the surrounding vegetation and soil, killing soil microbes. Volcanoes releases atmospheric pollutants such as carbon dioxide, steam, sulfur dioxide, ash, and dust into the air. And of course, this causes pollution of surrounding water bodies. Benefits associated with volcanicity. It results in the formation of precious stones and minerals. It's an important site for tourism. People visit volcanic sites to see on-the-spot assessments of how it looks like. It's the basis for geological researches, and it also leads to the formation of fertile soil for agriculture. Past questions. Number one, a volcano that has potential of future eruption is said to be A, destructive, B, active, C, extinct, B, dormant. We have to contemplate our answer between B, C, and D. So the right answer is B, which is active volcano. Which of the following is not a byproduct of volcanic eruption? We have ashes, we have volcanic bombs, we have lava, we have cinder. The right answer there is option B, which is volcanic bombs. An intrusion of thick acid lava, which forces overlaying sedimentary rock layers to bulge into a dune, may cool and solidify to form A, batholith, B, laccolith, C, dike, D, lapolith. The right answer is laccolith, option B. Thank you very much for your time. In our future class, we'll be considering earthquake, which of course is a twin of volcanic eruptions.